Hello, my wonderful friends. Thanks for joining me for this episode where we have a very special guest. His name is Dr. Paul Clayton. He is a leading scientist in the field of nutrition. He is a former chair of the Forum of Food and Health in the UK and senior scientific advisor to the UK government's Committee on the Safety of Medicines. He's a clinical pharmacologist and the author of 6 books. I've read one of those books called Strengthening Your Immune System, How to Fight Infection, Allergy, and Autoimmune Disease. Now, I've been following Dr. Clayton for about 8 months, watching his information online, and I wanted to reach out to him and basically as a sort of fan of his work and supporter of his work, to ask him if he would speak with us today about prebiotic fibers and what they are, the connection between dysbiosis and our health, leaky gut, and autoimmunity. So that's what we're going to cover today. G'day, Dr. Paul.
G'day, Clint. Nice to meet you electronically.
Yes. We for those, what the reference there is that we met up in person and then we needed to get into separate spaces so that we could record this over Zoom. So thanks for joining us today. Why don't we start with the fundamentals? What is a pharmacologist?
You've got pharmaceutical or synthetic pharmacology, which is what I was taught at the Edinburgh University. And then there is the much more diverse world of what used to be called natural pharmacology, where we focus instead on the pharmacological attributes, that is, the very specific functions of foods and food derivatives. And it turns out that not only is this, as I said, much more diverse science than the science that focuses on synthetics, but it is also very much more important in determining our overall health and health prospects. So after I left medical school, which is a long time ago now, I started gravitating to the dark side, which is the non-commercial, at that time, world of natural pharmacology. And almost by default, I became known for doing this. I wrote a textbook on this, which is probably 15, 20 years old now, where I was trying to take all of this science that was being generated by different experts in different labs and universities all over the world, and tried to put it all together into something that was at least partly coherent. A little bit like, the first geographers who were putting together maps of the continents, the dark continents, such as Africa, going around the edges, and each one of them was contributing a little bit to the outline. And what I was really trying to do was to join all those bits up and show what this new dark continent might be. And I think I got a reasonable amount right. I got plenty of it wrong. But science, like history, is revisionism. You change, you adapt as you go. People come and tell you that really you made a huge mistake here, or you could have put it better there. And that's the most interesting and useful part of being a scientist, being a researcher. It's those bits where people can demonstrate to you that you're wrong. That's when you're forced to stop rebuilding the model and hopefully making it into something better. So I've been doing that for a long time. And that initial textbook, I think, was a stab in the right direction. Not a bad first attempt, I suppose. But I think we've moved on considerably in the last couple of decades. And are now at a point where we can actually understand with some clarity what the nature of the relationship is between the dietary shift which has occurred over the last 3 or 4 generations and the resulting changes in patterns of public health. Once you've got that background, we can begin to assemble or design antidotes to the modern diet and lifestyle that are manifestly harming us so much and in so many ways.
What would be some of the top few shifts that we have observed in society over those decades, or even prior, maybe in the last 100 years?
Probably the thought leader in this area is a man called Barry Popkin, who's an emeritus professor at the Population Center associated with the University of North Carolina. And he's published a lot of papers about this, which go back, I think, 25 years or so. And when he started talking about nutrition transitions, he was really originally talking about a period which was dominated by food insecurity. But when the foods that you did have access to were really basic produce, what you could fish or farm or hunt, to an era of not just food security, but food overabundance, and those foods no longer having very much to do with basic produce at all, but a diet which is now consisting more and more extensively of ultra processed foods. And we're like, Wile E. Coyote and those old Roadrunner cartoons. We run over the edge of the cliff. We haven't quite realized it. We're starting to look down. And what I'm saying, and what many other people are saying, is hold on, we've got something really, really wrong here. Because if you look at the trends for cancer, almost all the cancers, they're trending up. Heart disease is trending up again. Diabetes, the neurodegenerative conditions, allergies, and your own specialty, autoimmune diseases, all of these are going up. And the only things that are coming down are life expectancy and health expectancy, fertility, and IQ. We're in a mess, a real mess. And it's absolutely blindingly obvious that the pharmaceutical strategies, which is where the money in pharmacological research is, are totally unsuited to getting us out of this predicament. We need to look elsewhere. And it turns out that the solutions, which are becoming clearer by the day, derive from the world of natural pharmacology or from food.
You frequently use the word dysbiosis, and I've heard you describe dysbiosis as a leading cause, or if not the leading cause of diseases in our modern world. Would you define dysbiosis for us and clarify if indeed you do believe that, or if I've misinterpreted?
It's a gross misinterpretation. Dysbiosis is important, and let me just come back to that in a minute. But I think that where we've got to, this idea of diseases of civilization that are becoming so rife, increasing in frequency, decreasing in latency, and there's a huge problem. There's at least 4 major drivers. And one of those is chronic inflammatory stress, which dysbiosis sort of feeds into, but it's a different thing on its own. Type B malnutrition, and if you're eating a lot of empty calories and not that many calories anyway, you're going to be low in a lot of vital cofactors. Then you have something called glycemic mismatch, which is where we're eating a diet with lots of sugars and simple carbs. And at the same time, we're very physically inactive. So the muscles aren't removing all this glucose from the bloodstream. And then that leads to all kinds of metabolic problems as well. And the 4th major driver of disease, I think, is dysbiosis. So I won't say it's the most important. I won't even say it's primus inter pares, but it's certainly in the top 4. And I think the whole point of breaking down this very complex relationship between diet and lifestyle on the one hand and our increasingly sick society on the other, you have to move away from calling them diseases of civilization, because it's a resonant term, but it is very unhelpful. It's much too diffuse. What we need to do, what I've been trying to do for many, many years, is to parse the thousands of variables that are implicit in the modern diet and lifestyle. And from this noise, try to derive the drivers of disease. Once you've done that, and I think those are the 4 drivers I mentioned, you are then in a position for the first time to develop antidotes. But you have to be, more granular in your approach if you want to do that. And so this led to our developing an anti-inflammatory regime, a way to restore the micro and phytonutrient profile, which is the type B malnutrition, another strategy for glycemic mismatch, and a 4th to prevent or reverse dysbiosis. And what we find is, in the real world terms, when you put these 4 things right, most people, the vast majority of people who have a chronic degenerative disease, or let's call them diseases of civilization, that disease, the symptoms become less. In many cases, they go into remission. In the majority of cases, these people become pharmaceutically independent. Are they cured? No, I don't think that the concept of cure or prevention or maintenance, they don't actually make much sense when you look at the disease from this perspective. Now, that's the big picture. Let me focus in on dysbiosis. First of all,
before you do, if people at this point are thinking, wow, addressing those four things, that sounds brilliant. How do I access whatever it is that you've mentioned? And for the audience, I don't know what this answer is. So what does it look like? How do you help these people? And how do our audience access this as well?
Oh, right. Okay. Sorry, I wasn't really being commercial enough there, was I?
Okay, unless it involves some commercialism, in which case you could, speak in general terms.
Okay.
Whatever you like.
Well, this is a complex regime. We're talking about reconfiguring your diet or adding or creating a set of pharmaconutritional tools you can add to your diet that will basically take your metabolism, and send it back in time, put it in a time machine, send it back 150 years to a time before the industrialization of food. When you do that, what we think is going to happen is you will then assume not just a metabolism, but a level of protection against the chronic degenerative diseases that we know was the case 150 years ago. And we know this from the historical record. You don't have to go back to the Neolithic era to find a population that ate an ideal diet and was extremely healthy. You only have to go back, for example, to the mid-Victorian era, the period 1850 to 1895 in England, where they were eating a much, much healthier diet and had a health expectancy that was far greater than ours and a life expectancy that matched ours. So you can't put all this into a pill. What you can do is you can put it into 4 tablets, a shot of a rather complicated version of fish oil, a scoop of prebiotic fibers, and either some dietary and physical exercise changes or a couple of shortcuts, which we can perhaps talk about if you want to go there.
Wow. Yeah, I don't know any shortcuts to exercise, so that piques my curiosity.
Well, people hate this idea because there's this ingrained idea that we have that, no pain without, no gain without pain. And I like physical exercise. I mean, I walk or run with 30 miles a week, and I love doing that because I've always been involved in athletics, athletic activity, one sort of another, but not everybody does. And so I say to people, don't eat so much sugar, quite so much carbs. Do take more physical exercise, but some people won't. And of course, some people can't. So hemiplegics, paraplegics, people with diabetic neuropathy, with rheumatoid arthritis or other arthritides involving the ankles and knees and hips. So for people like that, there are shortcuts, there are hacks. And we can get into that at some point if you want to do so. But let's home in on dysbiosis.
Yes. And perhaps we can pick that up on another discussion another time.
Okay.
Yep.
Well, the hologenome, which is your genes, and the microbial genes, which far outnumber your genes, by the way, and that's the microbiome. A large amount of that, the microbiota, lives in the colon, but there's not a single physiological or anatomical compartment in the body which doesn't have its own microbiome. I mean, there are bugs of various sorts inside the central nervous system, in your lungs, kidneys, liver. They're everywhere. They're everywhere. And it's important to have the right numbers of the right ones. The extent to which we cohabit with them, it's incredible. They are absolutely interwoven through every one of our organs, every one of our tissues, and our health absolutely depends on them. Having them in the right place and the right time. Now, one of the places where you have to focus your attention to begin with is on the microbiota in the gut, in the large bowel to be precise, or mostly, because that's the where the largest numbers of these unicellular organisms live. If you are eating a pre-industrial diet, you're going to be eating quite large amounts of carbohydrates, which are non-digestible. So when you eat them, you don't digest them, you don't break them down into sugars, but they're fermentable. So they have a slightly different structure to glucose, sucrose, or starch. They pass through the small intestine intact because you can't break them down. You don't have the enzymes to do that. And they become fuel, not for you, but for the probiotic species that live predominantly in the large intestine. Now, because the bacteria that like to use this as fuel, they're mostly gram-positive. Because they're looking for fuel, they stay in the lumen of the gut. That's where they go to find their food source. And when they find it, they will take these fermentable carbohydrates and break them down into various short-chain fatty acids. And butyrate is the one that has all the publicity, but propionate in it is just as important. And what butyrate does is it's a very, very powerful anti-inflammatory compound. So it reduces inflammation in the intestines to a low and physiologically appropriate level. There's always going to be a low level of inflammation because that's where you are meeting the outside world, substances that you're ingesting. And the butyrate is also very good at one other thing. It's very good at killing cancer cells, or telling cancer cells to not just to commit suicide, but also to redifferentiate and become something close to being normal cells again, as opposed to being aggressive, unruly, and invasive. So if you're eating these prebiotic digestible fibers, you're encouraging the growth of the probiotic species, and they are saying thank you in a way. This is a very happy discussion that's taking place, or a collaboration. They are then telling your gut, don't be inflamed, don't be cancerous, and by the way, we'll do some other good things for you as well, because that is now being deeply implicated in, for example, various conditions in the central nervous system and elsewhere in the body. Now, we always used to eat these fibers. And so basically, the microbiota was always traditionally anti-inflammatory. This is a good configuration. What has happened is that, especially over the last generation or two, the development of the industrialization of foods, the formulation of increasing numbers of ultra-processed or processed foods, has led to a substantial decline in our intake of these prebiotic fibers, probably by about an order of magnitude, and in some cases more. So what that means is the probiotic species, they're starved. They don't disappear altogether. The numbers are sort of whittled down. There's a few still hanging on in there, but they're no longer able to do very much. And what happens is that their ecological niches that they occupied are taken over by other microbial species, many of which happen to be gram-negative. Now, I'm not saying that all gram-positive is good and all gram-negative is bad. It's not like that at all. But in the gut, if you're starting to develop overwhelming numbers of gram-negative species, there's a couple of characteristics of this population that isn't quite so good. So firstly, they're not necessarily saccharolytic. Their fuel source is not the fibers, the prebiotic fibers that the probiotic species like. Many of them are proteolytic. So they start eating up the proteins in the gut, and they start to erode or break down the mucosal layers that lie and over and protect the colonocytes, the cells that line the colon. So they come into direct contact with the colonocytes. Now that's one problem. The second problem is that they're gram-negative for a reason. When Niels Gram, the Danish microbiologist, developed gram stain, the gram-positive bacteria take the stain. They're gram-positive because of the nature, the chemistry of their cell walls. The gram-negative bacteria don't, because they're coated with a very waxy lipid substance, doesn't accept the stain, so the stain, they're called gram-negative. This waxy substance is something called lipopolysaccharide. Or it's a family of lipopolysaccharides. And they are extremely pro-inflammatory. So now all these gram-negative bugs coated in lipopolysaccharide are coming into contact with the lining of the gut, causing, obviously, huge amounts of inflammation, chronic inflammation. And the butyrate that used to be there is gone because those good bugs are gone. So now you have a totally different conversation or environment taking place inside the gut. This new microbiome, which is dysbiotic in the sense that it's no longer healthy, is creating inflammation. And inflammatory stress does two things. It encourages the growth of cancerous cells and tumorigenesis in general, plus metastasis and angiogenesis. But the other thing that it does is the huge amount of inflammation in the lining of the gut. The colonocytes start to separate. The tight junctions that normally hold them together start to take a different configuration altogether, and the normal barrier epithelial function of the colon is lost. This is what some people call leaky gut. And then various other things start to go wrong. For example, one of the things that starts to go wrong is that macromolecules, which should stay in the gut because you don't want them inside the body, now get into the bloodstream, into the portal circulation. And one of those is the lipopolysaccharide itself. This is a condition which is known clinically as endotoxemia. Now you've got these highly, highly pro-inflammatory compounds floating around in the bloodstream. Now, where does the blood supply from the colon goes? It goes to the liver. And this is deeply implicated in one of the factors that is driving the current epidemic of non-alcohol related fatty liver disease, which, if left untreated, will progress to non-alcohol steatohepatitis, and then to a couple of different types of liver cancer. And all of those problems are spiraling out of control. They're really, really numerically very, very important now. So that's one set of problems which is serious enough on its own. But the LPS doesn't stop at the liver. It's being circulated elsewhere. And now this is being implicated in cardiovascular pathology, in central nervous system pathologies. It's a mess. You're reconfiguring really a large part of your whole metabolism, and you're moving it into a direction which is involved, very obviously involved, in causing a wide range of different clinical disease states. That's bad enough, but wait, there's more. If the gut barrier function has broken down past a certain point, you now get what looks like the translocation, not just of macromolecules, but microbes out of the gut and into the bloodstream. And now you're getting mixtures of bacteria, some of which are extremely problematic, moving into other tissues in the body. And this is beginning to change our idea about what autoimmune disease might be. And this is where I think we're coming very close to your own main subject of interest, because rheumatoid arthritis is one of the conditions that we now know is associated with dysbiosis. How is that? Well, very recently, a rather beautiful experiment was done. And if I had all my papers in front of me, I could probably, I'd be able to impress you all by saying, oh, it was done by this group at this university, but I can't. But basically what they did was they took gut microbes and allowed them to be introduced into other parts of the body, and it triggered autoimmune disease. How is that happening? Well, the first models of autoimmune disease, and it was known that this very often followed an infection, was, well, it's molecular mimicry. There's a grouping on the surface of the target organ, which is a bit like the molecules that you find on the surface of the bacterium. So the immune response, which was directed initially towards that pathogen, once the pathogen is gone, that immune response, those antibodies, those adaptive immune cells, are now looking at the similar target, which might be in your thyroid or in your joints, and that's what autoimmune disease was. I was never convinced by that. And many other immunologists, serious immunologists, and I'm not a serious immunologist, said, we don't see how that's possible either. So this is where the new model comes in. Maybe when you have an autoimmune disease, your immune system isn't reacting to you. It's not reacting to your tissues. What it is reacting to is a component of the bacterium that in this case is migrated out of the gut. It's an intracellular pathogen. So it's got inside the cells in your thyroid or in your joints or in any other tissue where you have an autoimmune disease. It's inside the cells where the immune system can't get at it. But fragments of that bacterium are being expressed on the cell surfaces in the target tissue. And the immune system is now trying to attack the pathogen, and it's damaging the target site incidentally. That is not what it's actually reacting to, but it's the fragments of the pathogen. Now, there's the evidence is accruing to support that. There was this first little study that I told you about, and I've referred to that in my blog.
Would that fragment that's showing up in the surface of human cells that is pathogenic be a peptide, a small protein?
It might be, but I don't think anybody knows yet.
Yeah, right. Okay.
And some evidence for this comes from various trials that have been done treating autoimmune disease with long courses of antibiotics, which have produced some very positive results. I think until now, no one quite understood why that would be effective. But now we have a model which actually helps to explain why long-term antibiotic therapy could be effective. And interestingly, it is only those antibiotics which have the ability, however limited, to get into the cells. Now, I can tell you, and this is not yet published, but I think I can tell you without creating too many problems. There is a new antibiotic in town, which is actually it's effectively an amplification of one of the humoral components of the innate immune system. Sorry about the jargon, but at the end of the day, what it produces are effector molecules, which have a very low molecular weight of between 85 and 95. So unlike most antibiotics, where the molecular weight is probably 400 and up, these are very small molecules, and they can get into every biological space in the body. They can even cut through caseation tissue. So we're pretty certain this is going to be a very quick fix for tuberculosis. But the nice thing is, not only are these compounds do they get inside cells, but because we're mimicking the action of the part of the body's own immune system, it's absolutely non-toxic. You don't kill off the symbionts. This is designed to kill off pathogens, and it doesn't cause the other problems that antibiotics do, which can make you rather ill by killing off the good bacteria. This doesn't do that. So it's very specific, and it is very good at getting into cells. And the results coming out of this, and this is, I can't say very much more about it because, as I said, the study is ongoing. The preliminary results are absolutely phenomenal. The groups of patients with long-standing autoimmune diseases who are now they're off their meds because they don't need them anymore. Because the chronic intracellular infection that was creating the symptoms of an autoimmune disease has been cleared.
Now, so I'm going to get a lot of questions about this. Yeah. So to the extent that you can tell us, is it a natural antibiotic, or is it a synthetically lab-made thing?
No, it's natural in the sense that we use an enzyme that is derived from, in this case, because it's the best source, cow's milk. But the enzyme in cow's milk is almost identical to the enzyme that we have and that all other mammalian life forms have as well. What we then do is we take that enzyme, we stabilize it on an inert platform and feed it its natural substrates. And then the enzyme does its thing. It produces these effector compounds, which are hypocyanous ions and hypocyanate ions. And these are the ions that get into all of your tissues and wipe out the bad guys. And what we're seeing in the clinical trial, basically cure the autoimmune disease. Now, again, I've got to be very careful. I think we have to be when we use words like cure. Yeah. Because in patients like this, if they go back to their old diet and you recreate dysbiosis and you then start more of these bad acting microbes getting into the blood and getting elsewhere and causing problems, you're back to where you started. Yeah. So the way we look at it is, okay, let's restore eubiosis. So there's no more of these microbes getting into the blood. And of course, people feel better anyway, because if you have endotoxemia, you don't feel that great. So people feel good. And then we'll start bringing in this novel antibiotic treatment. And once the symptoms of the autoimmune disease have basically disappeared, we say to them, okay, now you have an obligation. You must make a commitment to maintaining a healthy microbiota from here on in. Otherwise, you may go back to the way you were. And this is very different from the way in which most medics practice. Most medics practice hit and run medicine. And they don't really, it's not particularly joined up thinking. What we're saying is, okay, there is an initial hit, which we can do with this novel antimicrobial compound. But then once you've done that, let's reconfigure you so that you're now in a holding pattern, which is not going to drive you back to either autoimmune or other forms of disease.
Which brings us back to the those four approaches that you mentioned before. I know one of the research areas that you've done very much so, because it's the Zinzino balance oil, which I have mentioned on a past podcast, but only in passing. We've never gone into detail about it. It's the omega-3 supplement that I take and recommend. You were part of the research team for that. In fact, sorry, was I incorrect there?
No, I didn't develop this. This was actually developed almost a quarter of a century ago by a group of Norwegian researchers, and I must give credit where credit's due. They were people like Osterud and Elvval, and there's a group of people who did this work. I mean, it's really beautiful work. I got into this much later, and I was probably the first person to explain why it worked and why commercial fish oils don't. And because of, there's a lot of cognitive dissonance going on here, because we have a lot of data that says eating fish, and particularly cold water oily fish, is very good for you, but fish oil is useless. And it's not just me saying that, it's the Cochrane collaboration, and they've come out with numerous studies which say that fish oil doesn't work, and we know it doesn't protect against cardiovascular endpoints, neurological endpoints, ophthalmological endpoints. It's just a washout. But why is that? Why are oily fish useful and fish oil isn't? And the answer, very simply, is they're two very different things. There's lots of things in an oily fish which aren't necessarily in the fish oil at all. So what we did, and what the Norwegian researchers before me did, was to reconstitute the oily fish by putting something very important back into the fish oil. And these are a group of compounds called polyphenols, and very specifically, they're amphiphilic, which means a part of the molecule has solubility in oil and part of it has solubility in water. What that means is these compounds will graduate around the surface of a droplet of omega-3 and stabilize it. And what happens in the marine food chains is they co-partition together from the marine algae that produce them both into the gut and then the body of the krill, the gut and the body of the pelagic fish, and so on, and all the way up to the apex predator, who might, in this occasion, be an Inuit, or it could be someone living in Tromsø, which is where a lot of the research was done. And all we've done with balance oil is to approach this from a slightly different angle. Instead of using the phlorotannins, which are the amphiphile polyphenols formed in nature, we've used equivalent compounds from olive, which taste a little better, and which also have connotations of the healthy Mediterranean diet. It's a little bit spurious in my view, but the physicochemical characteristics of the olive polyphenols are crucial here. They do the same thing as the polyphenols from the seaweed. And that's why anyone can produce a fish oil which would get into your blood, but it doesn't go any further. If the polyphenols are there as well, it'll get into your blood and then it'll be incorporated in your cell membranes. And that's where you need to have them. So I did a little bit. I added a bit to that, but I did not do the original work.
I've explained this before, and I think picking up on maybe something you said or a research paper I found, that in fact, some fish oils, in fact, it was your research paper that you wrote about the fish oils publication that you did, about how in some cases, when there is a lot of inflammation in the body and therefore a high degree of oxidation, that fish oils can be contraindicated in some elderly folks and those with high inflammation because of the potential, essentially the oils just get oxidized quickly in a body that has a lot of free radicals.
Well, if you co-ingest the fish oils with iron or heme or various other compounds like that, you will get an accelerated breakdown of these long-chain, highly unsaturated fatty acids. They're really quite fragile. I think the fish oil industry, made a huge mistake when they took the omega-3s out of the fish and stabilized them with D-alpha tocopherol or astaxanthin or ascorbyl succinate. Those antioxidants will keep the oil sweet while it's in a capsule or in a stainless steel holding tank, but not once you eat them. And we know this because, first of all, Cochrane collaboration fish oil doesn't work. But secondly, we've got this huge library of blood samples now, which is, I think, close to 1 million, which is the largest in the known universe by far. And what we know is that in Europe, for example, people who don't eat fish and who don't eat a fish oil supplement have a 6-to-3 ratio in their cell membranes of about 15-to-1, which is pro-inflammatory, which is why inflammatory disease is so common. If you take a fish oil supplement, that does bring the ratio down a bit from an average of 15-to-1 down to about maybe 11-to-1. So you're moving in the right direction, but you're still pro-inflammatory, which is why fish oil doesn't work. But in those very small communities that you still find in parts of the northwest of Europe, where people eat a lot of mackerel and herring and things like that, their ratios are down between 3 and 4-to-1, and they have they really don't have very much inflammatory disease at all. And if you take balance oil users, they're in that same group. So the omega-3s really are important. We always knew that, but now we know how to make them work. And it's by adding these very, very specific polyphenols, which are the chaperone molecules that nature designed to actually undertake that task.
Love it. Okay. Well, we had a great discussion around that was unplanned. So that's wonderful. If people are interested in this particular product, head over to rheumatoidsolutions.com/omega-3, and you'll learn more about it there. And there's a link there if you'd like to get yourself that particular oil. I use the vegan version of the oil and the lemon flavored. I found that one to be the best.
Have you tried the Tutti Frutti?
I haven't had the Tutti Frutti. Is there a banana flavor?
Oh God, I don't know. I mean, it's the food techs who do all this stuff, and I don't care what it tastes like. But what I do know is that the food techs have done a really good job in producing a product that I can actually drink, and I can get, my kids drink it. I grew up in the 50s, and in that situation, after the war, we were fed with orange juice and cod liver oil, and cod liver oil was a nightmare. I mean, it was traumatic having to drink that every day. Compared to that, these things are so much better.
Yeah, my 4-year-old asks for this particular oil. He says, "Is it my time?" I only give it to him every couple of days, and when he sees me have it, he says, "Is today my day, Daddy?" And he's leaning in, thinking he gets it. He also likes to look. He likes to be perceived as also like of high tolerance, like he's hardcore because he can have Daddy's oil. So he likes.
Yeah,
but it's
impressive.
not. No, it tastes great. Tastes great.
Well, I've seen the commercials for it. You see these models sort of sipping fish oil as if it was fine wine. I don't go along with it. It's not that great. but it's not bad.
I want to make sure we allocate enough time to prebiotic fibers.
Right.
So let me ask you a bunch of questions at once so that you can go on another thought roller coaster. Can we eat enough diversity of foods that contain a range of different prebiotic fibers to adequately serve our healthy bacteria to create butyrate adequately? So that's question number one. And then question number two, tell us about the product that you co-designed or researched yourself that can achieve this task.
Well, okay, let me answer them in order. Can we eat enough of all the right foods? And the answer is absolutely yes. You would have to do a little bit of research, and some of the foods wouldn't necessarily be easy to access. Phos and inulin, which are two really important prebiotic fibers, you can find in chicory root. And in fact, you can buy inulin 5-pound bags of the stuff over the internet. I think a lot of it is derived from either chicory root or Jerusalem artichokes. And that is half of the solution. It's not all of the solution, because you need a whole range of different chain lengths of fibers. And the importance of that is because the short chains ferment quite quickly, and the intermediate chains ferment rather more slowly, and the very complex prebiotic fibers take a long time to be broken down and to ferment. And the reason why you need this kind of time release approach is that once this blend of prebiotic fibers passes through the small intestine, it arrives intact in the large bowel, everything's moving. I mean, if it's not, you're in serious trouble. Everything's moving. And so what happens is the short fibers ferment first, and they're starting to give you this shift away from gram-negative towards gram-positive in the very top end, which is the ascending colon of the large bowel. And then as you're progressing through it, the longer and larger and slower fibers then start to take over. So it's effectively a relay race. And you want to be able to change the population of the microbiota all the way through the colon. And it's really important to change it also in the, not just the transverse, but the descending colon. You're getting towards the end of it now, and all the way through to the rectum. Because if you graph the frequency of tumors in the large bowel, they tend to increase in frequency as you get further down the gut. So you want to be able to provide a kind of protection, not just at the beginning, which is where inulin mostly comes in, but all through the rest of it. So we use a very small amount of FOS in the blend that I did design, a larger amount of inulin, which is a longer chain version of FOS, fructooligosaccharides, larger amounts again of 1,3,1,4 beta-glucans from oats, and then the largest amount of a much more complex and a much more slowly fermenting prebiotic fiber, which is called resistant starch, which you can get from sources like green banana. That was great fun to design, and that's actually my own brainchild. I mean, it was something that I actually spent a lot of time on because the maths are quite complicated. Because the very short chain fibers work really fast, and so their mode of action can be quite explosive if you take too much of them. You really only want just enough of the very rapidly acting fibers to start the process. The longer and slower fibers are easier, and the slower they are, the larger the therapeutic index. That is, the more you can eat, more you can consume before you start running into problems of, you start getting really windy, and then eventually you'll develop explosive diarrhea if you eat too much of them. So it was based on what is the fermentation rate of this length of fiber? What is the therapeutic margin of this fiber? What is the transit time in the large bowel? And I sort of juggled all these things together on the back of a very large envelope and finally came up with a kind of an algorithm, a set of ratios of these different fibers. So you start off with, 1 part of the FOS and 3 of inulin, and then 5 of, and so on. So it wasn't quite like that, but it worked out that way in the end. And at the same time, I was also very much at the forefront of my mind. We have to produce something that people won't have problems eating. It's got to taste reasonable. So we, tried a couple of prototypes, and we got to a version which people can tolerate really well. It tastes good. It's got a very mildly sweet taste, and it's thermally stable. So you can mix it into yogurt, whatever however you approach this, or let's say porridge. You can blend it into a soup or a smoothie. You can bake it into bread or biscuits. It's going to work the same way. If I'm in a hurry in the morning, I'll just take a scoop and throw it back, and then maybe a glass of water to wash it down with. I don't recommend that, by the way, for kids, because if you've got too much of this dry powder in your mouth and then someone pats you on the back and you inhale it, you don't want that. It's not a good idea. But it's very user friendly, and it tastes good enough so that compliance is not a problem. No matter how good something is for you, if it tastes really bad, compliance is going to fall off a cliff after a week or so. So this has really always been a part of our approach. We want something that is going to work. It's got to be measurable, and it's got to be acceptable. So I think that Xenobiotic, and in some ways, it's not a complex formulation, but it was a complex process to get it right. And I'm very proud of it.
Yeah, so you just mentioned the name of it, Xenobiotic. And people can get that from, why don't I put a link to that as well on the blog? If you go to the blog for this episode, just click on the link and you'll be able to get that if you wish. And just to repeat back so I understand, you've got you call it FOS. Now, FOS is an acronym for a very complicated molecular, is it fructooligosaccharides, or what's the pronunciation of that?
You pretty much got it, fructooligosaccharides. And people who've got SIBO, small intestinal bacterial overgrowth, need to stay away from FOS, and they need to stay away from xenobiotic, because providing the small intestine is working well and you don't have a bacterial overgrowth, you can eat these fibers, they'll get into the large bowel and they'll do their thing. And they're going to be really, really good for you, including because they're so anti-inflammatory. People who've got rheumatoid arthritis or any kind of inflammatory condition, really important. But if you've got SIBO, you can't eat these fibers because they're going to stimulate the growth of the good species, which are good microbes, but they're in the wrong place. So if they're now fermenting in the small intestine, producing hydrogen and also producing short-chain fatty acids, it's going to be uncomfortable. So if you have SIBO, you can't go down this road. You have to clean out the small intestine first, and there's other ways you can do that.
Okay. Did you want to give us just the headline of how you might, like, if someone does react to taking the prebiotic fibers, though, won't they also have some problems eating things like onions, which I think is another source of inulin, and garlic, although maybe small percentage? And I guess that's why on things like the GAPS diet, they avoid those if someone is having issues. Yeah. But ultimately, my view of this is that avoiding them forever is never going to enable you to have those important prebiotic fibers in your bowel to be healthy. So you've got to kind of get yourself back in there somehow.
Absolutely, because if you are on the FODMAP diet, and that came out of the University of Monash, by the way.
Sorry, I meant to say FODMAP. Yeah, not GAPS. Yeah.
Yeah, well, I wasn't quite sure where you were going with that, but
yeah,
FODMAP.
Sorry.
If you're on the FODMAP diet, that'll help to alleviate the symptoms of gastrointestinal distress caused by bacterial multiplication in the small intestine. But there's a price to pay. And that price is you're going to have severe dysbiosis in the large colon, the large bowel. And then over the long haul, that's going to create serious problems. So I think, yeah, you can do FODMAP for a while, but I really don't recommend you stay on it for long. I think it makes much more sense to normalize the microbial population in the small intestine and then start consuming the prebiotics. So how do you do it? Well, we took a leaf from the UTI natural sector. If you look at urinary tract infections, there are some people who have recurrent urinary tract infections, and there's various reasons for that. There may be an anatomical abnormality, they may be diuretic, diabetic, diabetes is another risk factor. But we know that those microbes, which are able to stay inside a hollow viscus where there is movement, in either the movement of water or in the small intestine, the movement of food, how are the microbes staying there? Well, the answer is they're locking on to compounds that are present on the surface of the cells that line the urinary tract, or in SIBO, the small intestine. The various microbes have got a portfolio of adhesins, grappling hooks, if you like, which are designed to grab onto these compounds on the surface of those cells. And that's what enables the microbes to stay there and maintain an infection where otherwise you'd think they'd normally be flushed away. So in the urinary tract, one of the really effective treatments for many UTIs is a sugar called L-mannose. And the reason why L-mannose is effective is because it actually is the same sugar that is expressed on the cell surface of many cells that line the urinary tract that the bacteria are grappling onto. Now, if you flood that system with that same sugar, it gets into this grappling system, it dislodges the microbes, and they're flushed away. So this is not an antibiotic treatment, it's an anti-adhesin treatment. So it's very safe, very effective, highly recommended. And I'm just wondering if there might be a similar approach that we could adapt to treat SIBO. Oh, sorry, you had a question.
No, because you're still on the same train of thought. I'm going to come back to this with the anti-adhesions with the seaweed, but we'll get there in a moment.
Okay. Well, I read quite widely, and you may pick that up from my blog. I'm not really a specialist. I have a kind of a magpie mind. I'm always looking for shiny little facts that I can bring back to the nest and try to make sense of. And I came across a very obscure reference in German folk medicine to a cure for what looked a little bit like SIBO. It wasn't really well described. And they used to treat these patients with carrot soup. And I thought, wait a minute. Let me see the recipe for that. I go back to the original herbal descriptions. And it talks about boiling the carrots in a certain way. It says you've got to wait until the carrot soup starts to turn a little bit sweet. I thought, oh, that sounds like L-mannose. But it's not mannose. You don't find mannose in carrots. But if you break down the oligosaccharides in carrots, which you do by boiling them to the point where the sweetness emerges, that's a sign telling you that the larger sugar, the carbohydrate molecules, have been broken down into smaller ones, which have this sweetness. The sugar that is produced when you hydrolyze carrots is working in the small intestine in the same way that L-mannose does in the urinary tract. So I thought, well, maybe let's see whether we can make this work. And we, tried this in a couple of people who had SIBO, and by golly, their symptoms kind of disappeared. It's not, I don't think it works in every case. Nothing works in every case, but it certainly seems to be very helpful in a significant number of people with SIBO. And I think what you're doing, because this is not an antimicrobial, I think you're dislodging these bacteria from their foothold in the small intestine. You're flushing them back into the large intestine, which is where they should be. And now you can start using prebiotics. And then the question is, how did these bacteria get up into the small intestine in the first place? And that's a different question. Yeah. And if you look at my last blog post, which is Everything in Its Place, a place for everything, I think, I go into that in much more detail.
What's that blog URL?
It's drpaulclayton.eu, so drpaulclayton.eu. And it's got to be there for as long as there is an EU, which is probably not for much longer, thanks to the incredible stupidity of Brussels and the idiocy coming out of Washington.
Okay. I don't know much about that backstory, so I'll stick to the questions about health. Okay. Let's do one more question, and then I'll wrap this up and see if I've understood what you've taught us today, and then if there's any final comments. The last question stems from something I read in your book, which I found really fascinating, and it was around the potential capacity of some seaweeds to dislodge certain unhelpful bacterial strains from our mouth, and therefore to essentially reduce periodontal disease.
Yeah.
Could you talk about that?
Yeah, sure. Well, this is another category of antiadhesion therapy. Periodontal disease is really, really common, and it gets more common with every decade that passes. And in fact, it's a more significant cause of tooth loss than dental decay is. You lose far more teeth through gum disease because the inflammation caused by chronic infection at the roots of the teeth leads eventually to the loosening of the ligaments that bind the teeth into the jaws, into the sockets, and then eventually they wobble and they just fall out. So if, when you're brushing your teeth and you spit into the sink and you see a spot of blood there, that's actually really serious. It's not a trivial thing. It's telling you that you have got periodontal disease or beginnings of periodontal disease. And when you see that, if you go to the dentist, they have absolutely barbaric treatments. They will sort of trim the top of your gums off, surgical debridement, which, and then you have a mouthful of blood and you have less gums. And each time you do it, you're actually destroying tissue. It doesn't regrow. It's not very sophisticated at all. It's typical first order thinking, which has no place in dentistry or in medicine. And again, I'd been looking through the literature and I'd come across some references, this time from the world of veterinary medicine. And there was a small company there that had been using a seaweed, very simple seaweed extract, actually really just dried, granulated or powdered kelp, which they had shown reduced dental disease in cats and dogs. And this was a veterinary product. So I started looking at it. I started jumping into the wider scientific literature. And it turns out that these seaweeds, and in fact, almost all seaweeds, contain anti-stick or non-stick compounds called fucoidans and funorans. And these are polysulfated oligosaccharides, to give them, their full title. And they act like the biological equivalent of Teflon. Why do the seaweeds make them? Because it's to stop fouling. Because otherwise, species, like barnacles and other types of species, would be continually infecting, settling down on the seaweeds and basically killing them, smothering them. So the seaweeds produce this in order to remain free of infestation. And when you eat those seaweeds, and you can eat quite a lot of different seaweeds, there are one or two you shouldn't, you're ingesting these compounds. And it turns out that after a while, the bacteria in your gut adapt to the point where they can use these compounds as fuel. They develop a set of enzymes to metabolize them, and they break down these larger molecules into slightly smaller ones, which you can then absorb. They get into the bloodstream, and then they're secreted by the intraclavicular glands that you have between your teeth. And so they bathe the roots of your teeth with these, non-stick compounds. And when you do that, within a day, you can see that plaque starts to disappear. And you can see this for yourself just by using those, plaque disclosing tablets you can buy off the internet or get from your dentist. So, the one day you're all stained horrible red or blue or whichever the color is you're using. Use these fucoids for a couple of days, and you'll see that most of the stain is just gone because the plaque is not able to form on your teeth anymore. And then if you keep on doing this, after about 3 or 4 weeks, tartar, which is mineralized plaque, just crumbles up and falls off the roots of the teeth. And when that happens, the periodontal disease goes away. The inflammation goes away. The dysbiosis in the oral cavity is resolved. And now your gums stop bleeding, your teeth settle themselves back in the sockets, and you have at the same time removed a major risk factor for Parkinsonism and Alzheimer's. Because dysbiosis in the mouth, you're producing these nasty inflammatory compounds and bacterial toxins that are being processed. They get into the olfactory nerve, they move retrograde in the olfactory nerve, and they get into the brain. And bad oral hygiene and periodontal disease is inextricably connected to neurodegenerative disease. You don't want to be importing these toxins into your brain. So these fucoids and fumarins are not only protecting your teeth, they're protecting your brain as well. And there's one little last wrinkle. If you're eating these on a regular basis, which I do, and they're in the blood, you're protecting yourselves against prosthetic infections. So a lot of people now walking around with artificial hips, knees, heart valves, and things like that. And what seems to happen, what we have known actually for quite a long time, is you might recover from the initial surgery, you might be fine for a couple of years, and then one day you wake up dead, or someone else wakes up and finds you dead. And when you cut this person open, you find they've got a deep infection on that artificial heart valve, or on the knee joint or the hip joint. I mean, this is why, for example, every time a dentist does a dental extraction on someone who's got a prosthetic device, they shoot the patient full of antibiotics first, because when you do a dental extraction, you get a big transfusion of bacteria into the bloodstream. And they're in the bloodstream, they don't settle down anywhere until they find the prosthetic device, because that's not immunocompetent. So they settle down very happily, they start to grow, they produce biofilm, and a year, 5 years, maybe 10 years later, you're in serious, serious trouble. Yeah.
Obviously I'm in Florida now. Our neighbor is a good friend of mine. His name's Patrick. His father just died a month ago from a pulmonary embolism. I said, what happened to him? He said, well, he had his hip replaced 4 years ago. It became septic. He had to have 3 subsequent surgeries to try and get rid of the bacterial infection in the hip.
Right.
And he said after his last surgery, he's in so much pain and there's so much problems with the surgery. He said, I'm just not going to get any more surgeries. And then he was sleeping a month ago and died in his sleep. And evidently it was related to, associations with this hip replacement. So it's very, very real for a conversation I had 3 days ago.
No, this is a very real problem. And as the numbers of people with prosthetic devices inside them continues to increase, it's going to become a more substantial long-term medical complication. If you look at the figures for iatrogenic illness, they're already very substantial. But I think they're a gross underestimate, because they tend to miss these long delayed cases where the harm is caused by a post-operative problem, which is a very insidious and slowly developing one. I think if you were to be able to identify all of those cases and add them to the numbers of cases who we know, uh, because of the shorter duration between time and effect, are being harmed by medical treatment, either in hospitals or in the short-term aftermath of hospitalization, I think that the iatrogenic deaths would probably go up a couple of notches on the league table. And we might even find that they're right behind heart disease and cancer. Now, that's a worst case. Maybe I'm being a little pessimistic. This is a very, very real and it's a very extensive problem. So I would say that anyone who has a prosthesis would do well to include a fucoidan or a funorone element or supplement in their daily regime.
I have a strong recommendation and inclusion of dulse and wakame and nori in our program for none of the reasons that you mentioned. So it's just another argument or another reason to include these seaweeds in our diet on a regular basis. So that's a wonderful reinforcement. And just before we sort of wrap this up, a comment here. There's a doctor who practices a lot of ozone therapy called Dr. Robert Rohan out of California. He published a study a few years ago that showed he was able to take a patient who had a bacterial infection in their knee replacement, and the person was going to undergo, a revision surgery and would be on systemic antibiotics for a long time and so on. And he used ozone gas directly into the joint on multiple occasions and was able to then reverse and clear out the infection with injected ozone plus a local or just a tablet antibiotic. Just thought I'd mention that because, I thought that's pretty interesting.
I hadn't heard of that approach before. I mean, I guess it makes sense. The other approach that I would take if you actually had an existing infection, that one that I mentioned before that has this very, very low molecular weight compounds, it's difficult to treat bacteria where there is an accumulation of biofilm. This is how the bugs actually protect themselves in a way, because you can't get the antibiotic into the biofilm in high enough concentrations to be biocidal. Though I think in a situation like that, this very low molecular weight antibiotic would be probably would be the first place. That's where I would start, because it doesn't require intra-articular delivery. You don't need to be jamming needles into your knees. It's simply basically it's a tasteless drink. It looks and tastes pretty much like water that you just drink twice a day for probably between 3 and 5 days, and that's it.
Now, that's on this topic again of this sort of naturally derived antibiotic. How can people, is that something that is commercially available or something that people can access?
Yes. There is a company in Britain, it's called Reg Chemicals, I think. They are a very small outfit and they are selling mostly to therapists. But the way to find them would be by putting into your search engine KIB 500. So that's Kilo Indigo Bertie 500. And I can tell you, I think without breaking too much confidence, that the reason why it's called KIB is because the person who discovered it wanted to call it Kiss It Better. KIB 500. And it's the technology is amazing. It's a real breakthrough.
Okay, wonderful. All right. Well, we've learned that, and I'm not going to do justice to all that we've covered. There's so much, but civilization has changed a lot in the last 150 years. We're eating far less fibers which are beneficial to our microbiome. I think you said of an order of magnitude. So we might only be eating 1/10 of the special fibers, which are a subset of just all plant fibers, but ones that are specifically beneficial to our microbiome. And it's hard to restore gut leakiness without covering the entire bowel length. And I love that imagery of we need to go coverage through the ascending, the transverse, and the descending colon, because at any point, if we've got this disruption to our mucosal lining and therefore intestinal permeability. At any point we have a leak in a long hose, then we're going to get this toxic substance that you've described as endotoxin or lipopolysaccharide. And when that enters the bloodstream, we get immunoreaction or we get inflammation. And that if our bacteria or undigested food particles are entering our bloodstream, we're triggering immunity or immune response. And I loved all the explanation that you gave us around, this potential new paradigm of what's causing autoimmunity, and not just the molecular mimicry model, but the concept that we might have these, subcellular particles in the lining of our own tissues that need to be removed through some other mechanism. So all this is extremely valuable. If we're happy to eat chicory root, green bananas, maybe some reheated potatoes, and we've got to eat some oats for breakfast. And if we eat, let me see,
seaweed, don't forget the seaweed.
Eat some seaweed, then we're going to reduce periodontal disease. We're going to restore gut health. We're going to have a better microbiome. We're going to produce tons of butyrate, which can fix up and heal the colonocytes, and we're going to do really, really well. And we also touched briefly on the oils to optimize our omega-6 to 3 ratio. So, I'm delighted and so grateful to have you on this episode. And I know that we're going to get so much positive feedback and probably a whole bunch more questions, but they're going to be from a more educated position because you've given us so much. So thank you very, very much, Dr. Paul.
It's been my pleasure, Clint. And if you want a rematch, let me know.
Well, why don't we pencil in a possible rematch and we cover off some things where we talked about exercise and we didn't find out this magical way of being able to get the benefits. We'll hold that one in the pocket.
Okay. All right. Really, really good to meet you, Clint. And next time you're up in this neck of the woods, drop in.
Thank you so much.
All right. Until the next time.
Bye-bye.